Present. Okay.
Okay, here we are. Nick and Ken, we're about to present our library dashboard presentation. Take it away, Ken.
Sure. So this project's purpose, as we've outlined to you before and through various documents, is to make the lives of librarians easier by gathering their data from the Excel spreadsheet, so that way they don't have to manually input it to find the data and then automatically output it as useful graphs. So the three main user requirements that we've achieved so far is to import the Excel data, analyze the data usage and make use of it, or make sense of it, and visualize the data usage through charts and graphs.
So what changed in our project plan? So we had a plan of how things were going to go and how we would use our time and how the velocity and the story points would be accumulated through the project, but things did not go as planned. Problems emerged and bugs came to us when we were working on the project. Basically, it comes down to when we were using libraries, some things were not working the way that we expected, and this forced us to basically readjust our product backlog. We thought something would only take a short amount of time. It ended up taking a lot more time than that, and then the product backlog was basically constantly changing. That was a big takeaway we noticed from this project.
So what changed in the software requirements? Well, our requirements and user stories did not change because we thought they were significant enough, and the librarians also through meetings we also thought the same thing. But the order of the requirements did change a lot from what was originally planned. So some insight we gained was that user stories were nice because they were lightweight to manage and we could understand them quickly. From here, we can create the product backlog and generate tasks into bite-sized forms that we can easily manage when developing this application.
So what changed in the software model? So the UML software model stayed pretty much the same, and we use that as a base for our software development. Notably, the design model, we really use that to guide our application. One change that we did make along the way is we switched our UML design into an MVC architecture, and we did that so we could achieve separation of concerns. Another thing is that at first we didn't really account for this connection between Python and JavaScript that we would be using in our application. So at first we didn't think of how we would design that in UML, of how the connection of Python and JavaScript objects would connect with each other. So that actually made the UML significantly more complicated. And basically an insight that we took away from this is that a software model is actually really useful when we feel confident about the design and confident that it won't change. Though when it's constantly in flux, it becomes a little more of a chore to keep maintaining it.
How does the design reflect the code? Well, the design should always reflect the code because we spent time making it and it will help us make code. But specifically, we found that class relationships are similar to how we intended. So a classes between a journal and a vendor are very similar, and we coded it in such a way that it does. The UML was very useful for giving us a direction to how to get started coding. So it acted as a starting point where we can direct where our classes are pointing to and see how classes are related to each other and how they interact with each other. One problem that we found was that some architecture patterns are hard-coded to a web application framework. So we were forced to use these patterns. So Flask has a very different architecture pattern than something in C# MVC or .NET MVC. So we had to readjust for those patterns and make changes for them so that way it more resembles a model view architecture than typical Python that just has all these all these methods within one Python file. So yeah, we made those changes in our project. One insight we gained from this was that looking at UML diagrams help enforce good object-oriented programming design.
Now we will take a look at the website itself. So we designed a web application using Python, and we have an SQL8 database on the back end. So just to remind ourselves, this is a library dashboard application. So imagine I'm a librarian right now, about to sign into the service, and I have an Excel spreadsheet of database, basically library catalog data usage, and I want to get some more understanding of the Excel spreadsheet. So by uploading this spreadsheet, I will get a visualization of the system. So I will start off. I've already made a profile. So I'm going to register a new user. So I'll just, for the sake of time, make a very simple one. And then automatically I've been signed in. Okay, so here I am. So the main use case is to upload an Excel file, right? So we're going to do that right now. This contains all of the data we want analyzed and visualized. We're going to upload it. We're going to press send Excel, and as soon as we do that, the Python is going to analyze it, and it's going to upload it insert it into the database. So that has already been done. After it's been inserted, we're going to take the data out of the database, and we're going to visualize it in this graph here, so we can kind of better understand about how the data changes over time.
So, for example, what it's showing here is that the journal title Nature at January 2011, its popularity only spiked to, the number of requests for the journal title Nature is 432, and as you go on into February, you can see it's 376, and March is 555. So from here, the librarians can gather more information saying that, oh, okay, the Nature journal was most popular in March as opposed to February, and they can adjust any details that they need to based on that information.
Just because we ran out of time, we didn't have a button here to change between the different journals that have been uploaded. Right now it's hard-coded for the Nature journal, but of course a librarian would be able to switch and see the data for the different journals.
By hard-coded, we mean that the Excel file had imported, or our Python application has parsed information from the Excel file, and then uploaded that into a database, and then the charts.
Basically, I meant it's fixed to only show the Nature data. There's other data in the system. It's just we don't have a control to check the other data.
Okay.
To wrap things up, we're gonna just go over some important lessons that we took away from this project. The first one is basically we made a UML diagram, and it was very useful in some respects. But in order to make a useful UML design model, we found that you really must understand the technology stack before you make that model. As we were mentioning before, Flask has specific architecture patterns that are kind of strict, and we weren't so aware of that before we started. So the UML design that we came up with maybe had to be changed in some ways just because of the way how Flask is strict in that sense.
Yeah. Another conclusion we took away was that software projects have more problems that you know. Now that we know better, I think we should plan appropriately for risks that may come up, such as a strike or such as unfamiliarity with certain libraries and certain bugs. So for the next time when we ever do a software engineering project, in class or in real life, we should create a better software risk management plan where it helps us recover from lost time from the strike or any other issues that may occur.
Thanks for listening, Magden.